Welcome to the 6th Stakeholder Day of the EIT RawMaterials Baltic Sea Innovation Hub. My name is Olli Salmi, and I'm the director of the hub here in Espoo, Finland, where we will be broadcasting the sessions today. Together with me on stage here is Mia Smeds, our communications manager, who will be your host today. So, what to expect from this morning together? Growth through innovation in the post-COVID world. Well, we are not in the post-COVID world yet, so the focus is very much into the future. At the same time, EIT RawMaterials turns 6 this year. So there are quite a few activities that we've done during the past years that are now bearing fruit and showing results. There are numerous technologies, processes, services being upscaled. There are students, professionals having received education, how to become an entrepreneur, how to innovate. And there are startups scaling up with EIT RawMaterials to really enter the business of the raw materials sector. So we will hear today from our industry partners, from universities, from research organizations and startups about their success stories that they've done during the past year. But the focus is not only in the past, so we also want to look into the future. We hope that this day, this morning, will inspire you. It will give you thoughts, and it will enable you to meet up with each other, start building consortia, and having those great proposals coming into the EIT RawMaterials pipeline as we have seen in the past years. Now, we are today making a hybrid version of the Stakeholder Day. This means that about half of the speakers are here in the studio with us, and about half of them are online, so bear with us. We will start with the industry partners with the EIT RawMaterials, looking at especially the critical raw material chains in Europe. We'll then move on to research and technology organizations to really get into how you get innovation to the market from research. Third, we will have our university partners telling and discussing how really to build the skill sets in young people and students that are needed in the future. And then finally, we have a selected number of startup companies that will pitch for us and for you about their project and their achievements. There is a chat box, should be a chat box in your YouTube, what you're looking at. So please use that. Put your comments and questions there. You can ask questions from the speakers, and we'll pick them up, and then you can join at least as much as possible in an interactive way into this show this morning. So once again, welcome. And I would next like to give the floor to the CEO of EIT RawMaterials, Bernd Schäfer, who will giving his greetings from Germany. So Bernd, the floor is yours.
Yeah, thank you very much, Olli, and I hope you can all hear me. Maybe a sign of feedback, Mia, just thumbs up, wonderful, okay. So first of all, good morning, everyone, and it's a pleasure being here, and certainly really wonderful to have such a numerous attendance in those unprecedented days. And for me, it's a pleasure greeting you indeed from Germany. I'm sitting here in our office in Berlin and watching at the Memorial Church, so that's quite impressive. So before we go maybe to this first slide here in detail, a couple of words about the overall situation in Europe about minerals and metals and what's going on. I just give you some backup information here that we are not really aware about all the time we are talking about raw materials and metals. And there's a combined value in Europe of 800 billion euros, also 13 million jobs standing for it in the raw materials sector. And with this, raw materials are very relevant for the industry. So we are, as EIT RawMaterials, a key enabler for the transition to sustainability in Europe, and will continue playing an important role to integrate the raw materials value chain, as well as facilitating matchmaking here between key actors. Similar, it's a bit like when I'm talking about the Raw Materials Alliance later, similar to the European coal and steel community in the 50s, in 1952, where the foundation of Europe was built on a European domestic market for raw materials. Our challenge today is to convert the old economy from the 50s, so to say, in a version 2.0, which addresses the societal and environmental challenges, to move from a linear brown economy towards a circular green economy, addressing the Green Deal and strengthening Europe industry's competitiveness, whilst maintaining and creating jobs for Europe. We have been over the last couple of months and weeks in intensive discussions with the European Commission. And in this regard, I also would like to quote Maros Šefčovič, who clearly highlights the challenging situation that Europe is in when we are looking at raw materials, which are indispensable and of utmost importance to support this sustainable growth that the European economy is in need of, and to drive the transition at the same time to green energy. We are all reading and hearing this in the press every day, and this argument becomes even stronger. So raw materials are essential to ensure a permanently positive development in Europe. And nowadays we are highly dependent, as we all know, on the import of raw materials and of critical raw materials from countries and regions outside Europe. Providing some context here, as you might know, on the 3rd of September, the new list of critical raw materials has been published, and a couple of raw materials like lithium and bauxite were added to the list. Certainly this was again strengthening the need for action. And one of the action points in there was clearly to appoint also, or to launch by the end of the month, a raw materials alliance in Europe. This is happening in the context of the intention to bundle the active partnership of the industry, and we have been, as European, as the EIT, as the European Institute of Technology, playing a very important role in there. And we can also present already now a vested interest of the industry to join and to follow and to support, endorse this European Raw Materials Alliance, not only for what we have been starting with, the rare earth elements and magnets project, but also in metals and materials along the key value chains. So we have been receiving more than 100 endorsement letters from the industry and the stakeholder community. And I think this is quite representative for a strong C-level interest and support of launching the European Raw Materials Alliance. For this initiative, EIT RawMaterials has been identified as the partner of choice, as the world leading raw materials network. And our expertise, we certainly can create an industry buy-in and also support RTOs, universities, associations, and NGOs. So as you see here in this slide, the Raw Materials Alliance will bundle the forces in an active partnership. We have been analyzing the key strategic value chains in Europe, and we have been looking at the full ecosystem by looking at those value chains where the predictions are quite disconnected from a supply-demand standpoint, looking into the future when we are looking at incremental demand patterns versus current supply situation. So our challenge here, and that's our mandate as EIT RawMaterials, as our mission also formulates it, to secure raw material supply in Europe, is also in the context of the European Raw Materials Alliance, to securing access to critical and strategic raw materials and processing know-how for the European ecosystem. And as I said, this goes along the value chain. It's addressing clearly the up, mid, downstream activities, including everything that addresses circular economy and the Green Deal. And we are looking at this from a short, mid, and long-term perspective on a horizon of 10 years. In this context, we have been identifying target investments to the extent of up to 30 billion euros for the next coming years in order to address and to support the long-term competitiveness of the European industry. So after a consultation process with the partners and also addressing mitigation needs of regulatory and financing bottlenecks, we will be getting back to our partners and intensifying the dialogues about potential investment ideas that we will bring into the Raw Materials Alliance. If we go next slide. The good thing here is that after, I cannot see the next slide, but maybe you can see it. Okay, you can, that's fantastic, wonderful, sorry Mia. And we're happy to announce today, and this was published beginning of the week, that the launch of the European Raw Materials Alliance will take place on the 29th of September under participation of high officials from the European Commission, from the industry, as well as from other stakeholders, umbrellas, and NGOs. So with this, we will keep you, of course, not only informed, but we will try to get you involved as your vested interest in the raw materials alliance and the sustainable supply in there is crucial to the success of these activities, where we will start with first actions early 2021. So with this, I leave the floor for questions and give the word back to Olli. Thank you.
Thank you very much, Bernd. This was very enlightening. And for those of you who want to know more about IRMA, please, in a few weeks, it will be launched. And you will find more information at EIT RawMaterials.eu. As Olli said a few minutes ago, we have 4 different sessions that this day is split up in. And we are now starting with the first one, where we will hear presentations from industries along the value chain. With me here today, as our first speaker after Bernd, is CEO Matti Hietanen from the Finnish Minerals Group. Welcome.
Thank you, Mia. Okay, good morning. My name is Matti Hietanen. I'm CEO of Finnish Minerals Group. And also on my behalf, I would like to welcome you all to this hybrid session, and also thank the organizers to allowing me to have this opportunity to talk here to you. So I will very briefly explain to you that what is Finnish Minerals Group, what is the core focus of our operations, and then give you an example of the R&D work that we do together with EIT, and then also give you some thoughts that how EIT can potentially support the let's say post-COVID growth of Europe. So Finnish Minerals Group is a state-owned holding and development company. We are focused on mining industry and on the creation of Finnish EV battery value chain. Our largest asset today is Terrafame, which is a nickel, cobalt and zinc mine in northern Finland, and Terrafame is currently building battery chemicals plant, which will start to ramp up after approximately 6 months from now. It is also worth to mention that we are the largest owner of Keliber, that is the most advanced lithium project in Europe. And I will briefly show you how these projects closely relate to the aim to create this battery value chain. Our mission is to responsibly maximize the value of Finnish minerals, Finnish raw materials, and then basically we have 3 operating areas. So first of all, as I basically already mentioned, we act as a long-term dedicated industrial owner within the Finnish mining industry. Secondly, we are very much committed to help to create the Finnish battery value chain. And thirdly, we also have a strong focus on R&D operations and on technological development. So if we look the EV battery value chain, and if we look the kind of like a upstream part of it, this gray area, we can see that through our assets, Terrafame and Keliber, we have a very strong footprint there. And when all of these investments that are now currently prepared, once those are ready, these portfolio companies will be producing substantial amounts of battery chemicals for EV battery production. But we don't want to stop there. We want to go forward in the value chain to cathode materials production and eventually to cell production as well, and not forgetting recycling either. And the way how we want to do this is that we are in discussions with industrial partners who already are in this business, and we want to invest together with them into new production in Finland. Well, then if we look the market, the estimate has been that at the end of this decade, Europe will need approximately 400 gigawatt hours of battery cells for the needs of European automotive industry. And if we look this picture showing the kind of like forecasted capacity that there will be at the end of this decade, we can see that if all of these projects that are in pipeline now currently, if all of those go through, we are actually pretty well aligned with that demand. But then if we looked at what it means and what it requires to produce 400 gigawatt hours of cells, we can see that it basically means that we need to have approximately 600,000 tons of cathode active materials and precursors, and obviously substantial amounts of different battery chemicals as well. And this is now obviously extremely interesting picture because now currently, for example, if we talk about cathode active materials production, there is none in Europe, so zero. So we need to build this whole capacity in Europe in few years. Obviously, we also could basically import these intermediates outside from Europe, but I guess that one of the themes of today is that we perhaps don't wanna act like that, but we want to have our own European production and value chain. Well, as you surely understand, there are a lot of challenges and difficulties in order to make all of this happen, and in order to kind of like speed up the technological development that is required to tackle some of these challenges, we have set up a R&D project with the help of EIT. So if we talk about precursor production, one of the key challenges is sodium sulfate discharge. So with precursor production, there is always quite substantial amount of sodium sulfate present as a discharged element as well, and that causes certain challenges for the investments. And what we are now trying to do together with our partners and together with EIT is to find solutions, technological solutions, where we could turn the sulfate discharge into a profitable operations. And then finally, if we think that how EIT could work together with the industry in order to support the growth in Europe, I could, for example, name three items. So first of all, I think that industry itself knows pretty well that what to do, but obviously EIT RawMaterials can help industry to go forward and focus resources to those needs. Then secondly, I think that there is a lot to do with policy and regulation, where EIT can as well work together with industry and help to develop the policy environment. And then thirdly, we need strong innovation capacity, which basically means more muscles to do the work that we are all doing. And I think that in all of these three areas, EIT RawMaterials can strongly work together with the industry. Thank you.
Thank you very much, Matti Hietanen, for this presentation. And I also would like to just address the fact that we have about 120 different people participating in this event at the moment, and that have been registered for this. And as you also know, it's streamed live on YouTube. If you have any comments or questions, please don't hesitate, just use the chat box. I think it's supposed to be on the right side. Yeah, and then write them there, and we'll see, we'll do our best to get them answered for you. Our next speaker comes from one of the founding members of EIT RawMaterials, Metso Outotec. You your name is Kai Jansson, and you will tell us now a lot more about a few of the projects that you have been very active in.
Absolutely. Welcome. Thank you, Mia. So, ladies and gentlemen, thank you for giving me this opportunity to present Metso Outotec sustainability project, which has been funded by EIT. But before I'm starting, I need to show you one picture regarding Metso Outotec. This was a merger in between two big Finnish mineral industry technology providers in the summer, and it means that we are now becoming one of the biggest ones in the world in this field. And sustainability is extremely important for the company. For my part, this started everything in Finland in 2012 with one of the famous dam breakage, and we started to think about that, how can we avoid these kind of things of happening in the future. So we have been already working 8 years on the topic. And one of the points I was asked to kind of address is that how are we coming up with these kind of cases? Fundamentally, lots can be done inside the office, but it's very seldom it's really kind of taking air under the wings. So we prefer to discuss with the customers and follow up our main customers in the field. This is extremely a good point coming from Anglo-America since last year. They are really kind of addressing that the water is really an asset. It's nothing more than a real asset. Many of these kind of new cases which are coming up in the world are belonging to areas where water is really scarce raw material. So if we want to kind of go into that way and follow the industry, we have to come up with the new technological solutions which is kind of making this possible. And you are talking about very big amount of money what you are talking about, so these are not small ones. So keep that one in mind. Second issue what you have to keep in mind is the investors. It's not only our customers who are the mining operators, there is investors behind it. There are insurance companies who has to pay in terms of an accident which is happening. And they are stressing that there shouldn't be none of these mining companies that doesn't have these sustainabilities anymore on their strategical agenda on annual basis. So everybody is now looking for the way how can they become more sustainable. This is also driven by the fact, I think that many of you have seen this kind of maps before, which is a map about water scarcity in the world, where the yellow one is less known and the red is extremely heavy water scarcity. So there's basically not much of water available. And there is also dots kind of pinpointed on the map, which is telling that where you have the mines allocated today. And you can see that these match extremely good in between each others. So we can really see lots of mines in desert zone and extremely water scarce area. So whatever is kind of done from the technological point of view, we have to address this situation. So what have we been doing in Outotec? And this is one of those projects which we have been focusing on, and this is what we call the Outotec Water Advisor. When you start to kind of make a new development for a new site, and you want to stress the water, many of our customers, it's very difficult to start because they don't have the basic knowledge of what they have on the site. How much water they have, what's the quality of the water, is it available around a year, etc., etc., etc. So this is the first tool which is trying to address that one. And it's not only a kind of ordinary mass balance tool, this is also based on chemical reactions and assays. So we can really tell that what is the stuff which is, and the water quality, what you have in different places there, what can you use where, how can you connect it in a different way so you can lower down the water usage. And we are talking about fresh water usage. And just to kind of pinpoint for socio-political issues, the most important parameters is that how much are you using fresh water and how much of effluent are you generating. Those are the points what we try to address. At the simultaneous time, it's not allowed that you are weakening your process performance. So it's just not to kind of connect the effluent to the raw water stream and say that now we are closed. You have to have something else here. So this has been a huge effort and help from the EIT RawMaterials. Then this is of course one of those steps. The second step on this one, it's not funded by the EIT yet, but this is really to make it work. So first you have the program and the systems which are telling that how it's possible to make, and you can play around it. The next step is to close it really up. And that work we have been doing. But once again, if you see the graph on the screen, you have the water balance in a typical case on the upper part, and then a closed one in the lower part. And you see a blue dot, which is representing the process water, which is in extremely tight closed system. You understand that that water has to be also cleaned in some way, but not in the similar way as you need to clean wastewater. In this lower part, you don't generate any wastewater. So absolutely a benefit. So it's a totally new game, and hope that we can discuss about that later on in the upcoming years. So from the summary, whenever you are going to start with a new idea, there is, I would say, a couple of main things what you have to always to look for. What is the external people thinking about your project? Personally, I always start from them. I always go to the sites and kick the stones. That's absolutely the best way of how to ensure that you have right type of project in your hands. So basically following the customer needs. The next topic is more or less that you want the customer to say what you want. Then you know that it's sold. However, this is not possible if you don't have a good kind of networking behind you. And I think that in this case, EIT has been showing extremely good resources for us. Thank you. That's the way how you can build up all these cases. But remember, it is very good that you have this external part covered. But the big fighting ground is always the internal sales. So be sure that you have it. You are sure that you have the resources allocated, you have the funding allocated, everything of that once. Follow the timelines and the milestones. I think that then you are good. So by this one, I would like to stop my presentation and only kind of show you this famous statement by Albert Einstein. Sorry. So thank you.
Thank you very much, Kai Jansson. We will ask Kai and Matti to join us after the third speaker, which is joining us online from Sweden, Höganäs. Her name is Dr. Rosmarie Yttergren, and she represents Höganäs, a global leader in the metal powder industry, and also one of the founding members of EIT RawMaterials. During the years, the last 6 years, Höganäs has had several really successful projects together with EIT RawMaterials, and now she will have a few minutes to present a few of them.
Well, thank you, Mia, for the presentation, and also thank you for having me as a presenter here. And I hope you can see my slides. It looks good from my side at least. And as Mia mentioned, I will present some of the projects that we have been working with within the EIT RawMaterials. But I would like to start to make a short presentation on Höganäs, because it may not be very known to everyone. Since we are quite far back in the value chain, you may not think of where you can find Höganäs in your daily life. And actually, you can find it everywhere in your everyday life. I guess some of you took the car to the work or to your offices this morning, and in every car there is several kilograms of Höganäs powder components, different type of components. Maybe you used your hand tool machines this weekend to fix something in your houses, and there could be some electrical motors made of Höganäs powders. Or you had your morning cereals eating this morning, and maybe they were iron fortified by Höganäs products. So there are several ways to find Höganäs products. Höganäs is a very old company. We were founded already in 1797 here in the south of Sweden, in the small town of Höganäs. And during the years, we have changed the technology or the scope of the technology. We started as a coal mine, and then we turned into a ceramics, where we did a lot of pottery, of course, but also tiles and other type of building blocks and so on. And it was in the beginning of the 1911 where we started actually to do metal powders. And maybe you have been to school and read about Höganäs sponge process, which actually is the same process that we still have, and that was started in 1911. And we have expanded over the world to be present close to our customers. And we entered Asia very early, and it says here that we were the first Swedish company in Japan. I cannot verify that, but if it's here, I hope that is true. We have done several acquisitions over the year, and the last one we did was to incorporate a part of HE Stark, the division of surface technology and ceramics. So we try to we have the ambition to follow the different technology shifts, and now we have the challenges that I think most of companies have with electrification, digitalization, and customization, and of course the need to become climate neutral. Here's some numbers to get an understanding of Höganäs. We have an annual production capacity of 500,000 tons. And now I'm just talking metal powders. And that is what we are selling. It's metal powders, nothing else. We have about 3,000 customers in different countries all over the world. We have 3,500 different products that comes from different production sites over the world. I will show you a map soon. And many of these products are customer mixes that are made for the special customer or for a special application. We are about 2,500 co-workers. Most of the part are sitting in the small town of Höganäs, where we have the head office. And we have a turnover of 10 billion euro about. We are a very technique-heavy company with a lot of R&D, and during the years we have applied or granted 1,000 patents. We are a privately owned company since several years, and we are owned by FAM, which is about part of the Wallenberg family, and 50% of Lindén-gruppen, which is a local family here in the south of Sweden. We have a wide range of different type of powders. We have sponge powders, as I mentioned in the beginning, talking about the history. Then we have different type of atomized powders, water, gas, and plasma. And we have these different type of process routes to get different morphologies, chemistries, and so on, so that we can provide the best solution for the customers. And with the acquisition of HE Stark, we also now can offer ceramic powders. And then we have different annealing and mixing capacities. Höganäs is always close to the customer. You can see from the map that we are very spread over the world. As I mentioned, in Sweden, we have the headquarters with the corporate functions and also the main R&D functions. And then we are spread with production facilities and tech centers in United States, China, India, and Germany, and also some smaller production sites in Great Britain, Belgium, Korea, Japan, and Brazil. And then we also have sales offices. And with all the different processing routes and R&D that we're doing, of course, we might want to offer more effective, lighter products with reduced environmental impact to the different industries. So that was just short about Höganäs. Now I would like to talk about some of the EIT RawMaterials projects that we had from the very beginning. And here are most of them, and there have been in different areas, both networking, education, and upscaling. Most of them have been very successful. I would like to point out the first one, the ERMAT project, which I found was very successful, but we didn't, for different reasons, we could not take it all to the end. But that was about building a network where you could offer different side streams, and people could get into a website and discuss and buy and upgrade different side streams. Unfortunately, that didn't go all the way, but all the material is there if someone would like to pick it up. I would like to stress on 3 upscaling projects that we have finalized and that are ongoing, and that are the ones you can see in orange here. It's the MinPet, a mineral product from Petri T side stream technology. That Petri T is a slag. And we have the ongoing Spaceman, which is sustainable powders for additive manufacturing. And then finally, Newman, a new started project with nickel-free powders for high-performance components. So the MinPet, that is finalized, and the aim for it was to find new application for the side stream Petri T, that is a lime-rich slag that comes from the Höganäs sponge iron process. And there were 2 different applications that were explored, cement replacements and geopolymers. And this project is finalized and was very successful. There were actually parts built by both building blocks and acoustic panels. And Höganäs is now working on this to get it on the market. We don't have the production routes to do the production needed to do the building blocks. So there we need to find a partner to do this for us. However, these are low price products and therefore very transport cost sensitive. And so we need to find someone in the close area. That has not been successful. So at the moment that application is resting. However, the geopolymer, there we are seeking partners, and that is for acoustic panels that you can see on the pictures also. And there are some promising leads. The Spaceman is an ongoing project to find a sustainable, low-cost and yield-efficient additive manufacturing powder for prototypes in car suspension, knuckle, and for a die for automotive sheet stamping. And in this case, it is to upscale new iron-based powders where you don't have a nickel and a reduction of chromium, and to use water atomization instead of gas atomization to lower the cost. Finally, we have the new one, Newman, which is also a raw material alternative, and that is for a shifter shaft sleeve that has not been done in powder metallurgy earlier. So that is a challenge that to make a new design, and it should be also produced in a sustainable, low-cost nickel-free powder. So here we take out all the nickel. And Höganäs have products that have high mechanical strength, resistance, and hardness that is fitted for this application, but you still need to have optimization and in the compaction and sintering and heat treatment phases, and as I said, also redesign. So this was a very quick presentation. I see that I have to end it here. So thank you.
Thank you very much, Rose-Marie. Now I will ask Matti and Kai to join me here, and Rose-Marie, please continue being with us on Teams, because now we have a few questions. And first I have to ask Olli, have we had any questions from the audience?
In the CapEx stream we don't have.
Yes. Not yet. Then I'll start with this one. Yes, please use the microphone. The European Commission, in their COVID response, they talk about a need for shortening and strengthening the supply chains. How has COVID-19 affected the global supply chains in your mind? Matti, would you like to start?
Well, I think that is a good question, and if we consider, for example, these new investment projects that we are preparing, this kind of like a European lithium-ion battery value chain, I think that the kind of like a key topic there is to make as robust value chain and supply chain as possible, because basically this pandemic has been a clear example that there are real risks with long value chains, and I think that is something that we have witnessed already. Yeah.
What about you, Kai? And
I agree totally what Matti says, that what I have been also seeing, that it's becoming more local. So more local focused, everything has to be taken more local, and that's a clear signal.
Would you like to add something, Rose-Marie?
No, I can just agree to what the gentleman said here.
Thank you. There was a lot of concern about that last spring, but how does it look now? When you're looking ahead, maybe 1 year, what are you seeing? What kind of development?
That was a quite big question.
Yeah.
So I would say that if you think from the metal point of view and sustainability point of view, I think that the precious metals are absolutely on the top of the game still. And rare earth metals are still there. It's everything about shortening all the lines, supply lines. And I think that the sustainability is something that we cannot afford to lose.
Yeah, I think that there are many big kind of like a mega trends now out there which affect the business environment, and obviously this COVID-19 is only one of those. For the mining industry, I think that the kind of like a geopolitical tension that we are witnessing has also its impact, and also the kind of like a more broader economic uncertainty. So this is something that is really difficult now to forecast that where things go. But on the other hand, for example, in our operations, this battery development is something that is going forward even stronger and speedier as was forecasted. So I think that is something that will not be affected of this crisis.
Rose-Marie, would you like to add?
Yeah, I think that the COVID-19 has opened up the awareness of vulnerability on the supply chain, and I think that has made people or companies, industries to think more carefully what you do, where you source your material, and that also have a very positive effect on the sustainability actions and also the climate.
You were nodding here, Matti. Would you like to continue on that?
Yeah, I think that you're absolutely right. So basically, I think that people are more now ready to pay attention to these kind of like let's say nature-related risks that we are witnessing here. So I fully agree with what you said.
All of your companies operate on a global level. What are the strengths and the weaknesses of Europe in terms of skills development and innovation when we compare to other regions?
Once again, a complex question. Maybe if I try to simplify it as much as possible, I think that being a global company is the benefit that you are able to picking up the weak signals very fast and utilize those ones to strengthen up your center of the core, which is in our case is it in Europe. So I think that's absolutely a benefit.
Are there any other benefits?
Let's Matti kind of continue on this broad question, and I will have a little bit time to think what else it could be.
Yeah, that is a very difficult question, and basically I would say so that we can have many different kind of like approaches here, but basically I guess that broadly speaking we have like a European market, European research sector. We have similar in Asia and in the US, and perhaps the question at the end of the day is that are we as Europeans, are we hungry enough? Do we work enough in order to do those innovations? Are we eager to go forward?
Okay.
Oh yes. No, thank you, Matti. You open up another gate. Absolutely big benefit in this European community is that we have different cultures. And different cultures comes with different languages, and those typically leads to different thinking. So we have the very good possibilities now to tap on the brains of different European people and nations, and try to take out the best of the rest. And that's a real benefit that you don't have anywhere else in the world. You might have a big pool of people, but they think in the same way. It's a little bit more difficult to go out of the box. That I see as absolutely a good thing.
Are we good enough at doing this in Europe?
Matti?
Well, I don't see any reason that why wouldn't we be? So surely we are, and we have all the competencies and obviously we are global leaders in many sectors now. If we look in the near-term history, obviously Asia is very strong. For example, last year 99.7% of precursors and cathode active materials were produced in Asia, and that basically tells something about the competencies as well now currently. But obviously now Europe is going strongly forward there as well.
So that's one of the areas where we can improve. Rosemary, do you have any other areas where you see that we can become better on a European level together?
Speed, I would say. I find that our colleagues in Asia, for example, think that we are working slow in Europe, and they are quicker action on things. And I think that is a benefit actually being a global company, because you get the speed and urgency from Asia, and you need to act on it, which I think is very good to have that as a close cooperation.
Yes.
But of course also I think it's to look on the climate. I think it's also an area where we need to work very close to our colleagues in Asia.
I think that you open up so many boxes here, so it's a little bit dangerous now. But I would say that you have to divide it to political benefit, economical, technological, decision making, everything on those ones. But something I learned this morning, I was listening to a very interesting podcast, was about warfare. And there is a really kind of different nations are doing it in a different way. If you go for example, towards very much west or very much east, it's typically based on rules. So you have to do this. If it doesn't kind of work, you go to the second. And if that doesn't work, then you have the plan C. And then if that doesn't happen, then you have something else. But that makes the structure many times, it seems that it's working fast, but it doesn't work out from the box. And that's something at least for the Nordic countries, and I think that many of the European countries in a similar way, because when you have a need, you have to develop. You don't have the time to kind of go through the rules. And the very first learning what you are given is that think out of the box. So this is basically pushed that you can follow these rules, but immediately if you have the possibilities to think out of the box, you go there. And this is, I say, it's very good for Europe because of this cultural difference. People have the different points of view to the box directly. And I don't want to go into the economics and politics, etc., because we don't have that time.
There's a question from the audience here. So out of one of the questions from the audience there was that, during the past 9 months now, during this COVID pandemic, has there in your mind been a change in how people perceive the mining industry or the importance of European mining industry? Has there been a change in this kind of thinking in your view, in your industries?
Well, I think that is kind of like a national question in a way. At least in Finland, the discussion around mining industry is very like a Finland focused, and I would say that in that discussion, perhaps there has been some voices supporting this, let's say, local supply chain and the kind of like rise of sustainable sourcing, but I wouldn't say that the big picture has changed as such with the public view.
Would you like to add on that, Kai?
I agree with Matti, 9 months is too short time, but what we can see that the stress, at least from the sustainability point of view, is still increasing. And totally agree with Matti about this. More local supply.
Rosemary, you're nodding.
Nothing to add. Yeah.
Yes. Thank you very much for this discussion. It's been very valuable to have you here presenting at this Stakeholder Day, and we'll continue being in contact also after this.
Thank you. Thank you all.
Thank you.
If you have questions or comments, please continue to share them with us close to the link that you're using when you're following this stream. Now we will move further to the next session, where we will hear the latest from the research and technology organizations in our innovation hub here around the Baltic Sea. These organizations are in a key position to move ideas from basic research to higher technology readiness levels, and further on to the market as products and services. But what does it take to move from research to the market? First, to give this question a shot is Dr. Tarja Laitinen from VTT, Technical Research Center of Finland. Tarja? We can't hear you. Could you put your speaker on?
Okay, now I hope it's better.
Thank you very much.
Yes, thank you, Mia. Yes, glad to be here on the virtual Baltic CLC Partnership Day. And the question of how to commercialize the research results well, I guess that we all have been practicing this more or less along the years, but how to do it efficiently? And of course, commercialization of research results, that is critical for company success. So how to come out to the market with these industrially viable, profitable, winning products. And I'd say that it is even more critical for research community. So how to provide impact from those scientifically excellent results. And the typical and traditional way of doing commercialization is through IP and licensing. So based on the innovations, then somebody is taking kind of the benefit out of, or then through spin-offs. But somehow often seems that there is kind of a missing link from the technology innovation to the industrially viable, scalable product. So there is kind of a gap there between. And now then the question is that how to commercialize efficiently. And here, the different roles and players are absolutely needed for the commercialization process. And the KIC's strategic agenda up to 2022, you see here, and now we are merely talking about the acceleration, so the green boxes, and how to make the best effort there. So KIC's roles here, KIC has the specialized services and capabilities in boosting and matchmaking, also financing and scaling up the services. So filling up the gap between the innovations and ready-made viable products. And then, of course, RTOs, universities typically being at the start of the value chain. So our everyday work is to deliver these high-quality scientific research results, the technology development steps, innovations. Typically, in our different kind of projects, jointly funded projects, we end up on technology readiness level on 4 to 5. So we have a lab or field-proven results. And then the really kind of party benefiting here and utilizing the research results in true world applications are of course the companies. So they are fulfilling their end customer needs and they need to make profitable business, and that all ends up to the good of the society. But then there's this challenge of increasing the technology readiness level from the here 4 to 5 up to the 9. So this industrial viable beneficially and profitable product. And through those end products comes the true impacts for the environment, for the people, for sustainability, for future. So these solutions for global challenges like resource sufficiency, sustainability, or carbon neutrality. And these we of course can see also in the KIC impacts, or how we are measuring that, how well we are doing on this commercialization path. But kind of the true impacts makes a difference for us all. And then of course I'm looking this from the RTO university researcher point of view from the start of this value chain. And now gathered here some thoughts with my colleagues that what VTT has gained from belonging into the KIC community, being a core partner here. And as you can see on the right-hand side, being a truly an active partner in this network. So VTT's project portfolio in EIT RawMaterials has been pretty large over the years, VTT being a founding member and core partner. And of course, upscaling is kind of the most critical and important pathway for us, but also education, so increasing our competence level. And then you can see that I think that we've tried all the possible project forms that there has been in the history of EIT RawMaterials. But kind of our most important gain is the increased understanding of the key challenges of the companies working in the field of raw materials. So as already discussed here earlier, on EU level, of course, there is all kind of demands and legislation on the operational environment that the companies and the products need to fulfill. There are even ever increasing demands for traceability and for sustainability, and also the measures for sustainability. So you have to prove that you are sustainable, not only like kind of marketing stories. Then there's always the cost efficiency compared to the competitors. You have to be efficient. Your products need to perform, and they need to be sustainable. There is a new list of EU critical raw materials, the availability. So the understanding the challenges. Then from RTO's point of view, from excellence to impact. So our everyday work, our everyday business is to provide the scientifically excellent deep science results, do the actual research work in the labs and in the field. But then turn that into impacts that has an effect on every one of us, and on our part provide part solutions to these global challenges. And that means that we need to go the path from research to commercialization. So not only these great results to enjoy ourselves, but how to make them benefit us all. Then also KIC has provided us the possibility for long-term development, as in this changing world, 2 years projects, they offer the long-term visibility on their part. Then, of course, as we be really active in the community, better visibility and acknowledgement by the companies. And then also new EU projects through the new partners that we made acquaintances in the raw material network. Then I have two examples of projects that we've gone through or currently going through this commercialization phase. So the first one, wear end project, where the whole wear resistant solution value chain is present. And here you see the companies partnering and working in the project. So wear causes a huge material and energy losses in the industry. And when we start from this TR level 5 with a novel material solution based on BTT patent, processing of nanocarbide, tungsten carbide, cobalt powders for wear-resistant coatings, and how to increase that on the steps of technological readiness level up to a industrial viable, beneficial, profitable product. And the companies here, yes.
Sorry, we cannot see your presentation anymore. Could you share it again?
Okay.
We lost you there on the last slide.
Okay. Okay, back online?
Yes, we're back.
Good.
Thank you.
Okay, great. Yes, so these wear-resistant coatings. And the target of the project, of course, is to produce superior performance wear-resistant coatings, increase their lifetime, increase the surface quality of the coated components in order to benefit the end users by coating quality, component lifetime, and also improved final end product quality. And upscaling and validation of the powder production and coating process with industrial partners, that is the way go forward. And here you see how the participating companies, what are their application areas. And 3 years later, we are expected to end up with this industrially viable product. Then another example, Kai from Metso Outotec already mentioned this water advisor. So this is a bit different approach. So Kai already described the challenges on the mines with water balance management, and now kind of this way of approaching from data collection and handling through analysis and modeling into business knowledge and decisions. So dynamic and predictive solutions for sustainable water balance management in mining. And real-time visibility, forecasting capability, the possibility to understand what's going on and to react on that. And like tailing areas, water ponds, they are of special interest, of course, because there is contaminated water that might interact greatly on the environment. So kind of changing that challenge from a kind of threat into a possibility, the water as a valuable raw material. And now, as Outotec already mentioned, it has been commercialized, and that same kind of TRL development from level 5 up to the level 8. And here you see also the partners in the project.
Thank you very much, Tarja.
Yes.
Now, again, we lost your presentation. And I will also ask Juha-Kaija, the next speaker, to be patient. When Tarja is finished, we'll be ready for the next presentation. So please, please, Tarja, could you show us your presentation once again? And sorry for this.
Yeah. Well, actually, I have the final slide here, and I think I can make it without that you see the slide. So kind of our thoughts for the even brighter future, what we are expecting or wishing for from KIC for the future. So the new partner promotion, especially for companies. The companies, the key actors in commercialization, and we are doing this for the company. So it's important that we have the companies that want to enter with their new products into the markets. And then also even more visibility for the important topics that we deal here in the Baltic CLC among the stakeholders. So like the visibility through different kind of position papers and positions in these public-private partnerships and different working groups on Europe level. And of course, the Horizon Europe and different kind of program preparations, that back office work there. And then also being even more attractive for the companies, this network needs to be quite clear on the financial backflow rules. So these are the thoughts, and sorry for the technological challenges.
Oh, thank you very much, Tarja. And it's from my part that I really would like to apologize for this. As you know, all of you who have been following this stream and participating as speakers, this is a hybrid and a little bit of a, we're out on deep water because we have 8 of the speakers scattered around the Baltic Sea, and then we have 7 of them with us here in Espoo, where we're broadcasting this event. Now, the next speaker is Juha-Kaija. Now, if you want to, you could start sharing your presentation because we would not have the raw materials we need for our products without the activities run by geological surveys, right? Therefore, I'll now give the word to Juha-Kaija from the Geological Survey of Finland. Are you ready, Juha?
Hello, Mia. Can you see my slides?
Yes, we can see your slides, and we can also hear you.
Okay.
Welcome.
Yes, thank you. Thank you, and thank you for the organizers for the invitation to this important event. And well, my name is Juha-Kaija, and I'm senior specialist in EIT RawMaterials project called MINEX and Horizon 2020 Mireo and Next projects, which have common. I mean, these 3 projects have a lot of common, and I will give you overview of first overview of GTK's activities in raw materials. So I present some projects related to raw materials. Then there will be a short intro to the market and especially our go-to-market. And then I will shortly list the benefits that EIT RawMaterials project have So first, short overview of GTK. So co-partner in EIT RawMaterials. Currently, we have 7 different units which are working in 4 focus areas: information solutions, circular economy, battery minerals, and water management. And especially
Excuse
circular
me,
economy and
Juha, I am sorry, I
battery
have to.
minerals are.
Juha, I am sorry, I have to
Hello?
interrupt you because we have difficulties hearing you with a good quality here.
Oh.
So could you please shut your video down? Not your microphone, only the video.
Okay.
Because
Just
there's
a
something with the internet connection. And then we will continue.
Yeah. Just a moment.
Just your own, just a picture. Yes, like that. Thank you very much.
Okay. And can you see the screen still?
Yes, yes, we can.
Okay. And well, I just took one recent example of the impact of GTK's work. It has been newly published that the Prime Minister about the economic value of Finland's national geography. And in terms of for the national economy, the estimated value of this database is 5.15 billion euros. So it's a really huge impact that GTK has, our care database has on the national economy. Here's the list of the GTK's raw materials related European funded from last 4 years. And we had a 4 EU contribution to this project was, and for GTK we got European approximately 4.6 million euros. And in green you can see those projects that are coordinated by GTK. Mining and metallurgy regions of Europe Union and the next new exploration technologies, they are ongoing projects. And but there is a lot of as you can see, we had a like biomore was new concept for extracting metals from deep. Also use biotechnology. It was really wide, and for this floating we have up to 40 partners. So network is also quite extensive.
Excuse me.
Yeah, the raw materials project. Hello?
Hello, Juha, we have difficulties hearing you. We can. I believe that there's something wrong with the internet connection. So I will unfortunately have to cancel this presentation because we can't hear you properly.
Oh, okay.
Yes, I am very sorry to do so, but what I will be able to do is to send your presentation as well as all the other presentations to all the participants that would like to hear more.
Okay, this is a really pity.
Yes, it is. There is something with the... Can you hear me?
Yeah, I can, but I'm really sorry because we had yesterday we had such a good connection and I could hear everything, but it's a really pity, but what can you do? So
yes, I am sorry. We were discussing we had a few questions for you and for Tarja that I would like to ask you. Would you please stay with us, Juha, for a few minutes? And I will, let's see if we will be able to hear you properly. We have been focusing on, together with Juha and also with Tarja, on the key success factors for a research and technology organization. What are they to be able to succeed in the raw materials field? Would you like to start, Tarja?
Well, of course, understanding the needs of the end customer and understanding the value chain, so kind of the different competencies and frame boundaries existing on the value chain and able to develop competencies accordingly, and of course in really tight cooperation with the companies and with other partners.
Juha, would you like to add on that, your point of view?
Yes.
Thank you.
Yes, first, and tell me if you cannot hear me properly. So, well,
We'll try.
first, of course, this EIT RawMaterials is one of the key instruments for GTK's research and innovation active. And I can give you one example of the good cooperation with Finnish SMEs. Well, it's about the Finnish company called Radai, who is a partner in Horizon 2020 Next New Exploration Technologies project, and also this year in July, Europe is innovation radar.
No, I am so sorry, Juha, but
novel electromagnetic.
You are disappearing. We can't hear you properly. I'm sorry. I have one last question, and I would like to approach you, Tarja, again with this question. How do you place the level of research and development in Europe versus the rest of the world?
Well, Europe is investing quite heavily on technology and on research and development, and that's, of course, it serves us all. So like on our part, delivering the possible solutions for those global challenges we are all facing, like related to scarcity of raw materials. And then, of course, Europe has this kind of own viewpoint and own frame there. But yes, the kind of level of public funding on research in Europe, that's really on good level, and that gives kind of the possibilities for us all to make these great technological innovations and benefit for the society, people, sustainability, and for a better future.
Tarja, ask also a question because it was one of those myths along the idea that we need shorter value chains, and that was, that was somehow demonstrated by the COVID crisis. Another one of those ideas then was that now is a good time to focus on R&D because the market is lagging and stalling, and now would be a good time on focusing more on R&D. Do you see that from the VTT point of view that industries or you would have more R&D activities than 9 months ago because of the COVID? Has that had any impact?
Well, I must say from VTT point of view that currently we see kind of no change due to COVID. We were expecting quite a path due to these unexpected events, but at this point, VTT's kind of from VTT point of view, things are proceeding quite much as normally, and as we are all facing this challenge, so these kind of events and discussions with the customers through Teams, through different kind of virtual meetings, they're working very well. So we are all bringing our efforts towards the same target. But I'm a bit afraid that in the coming months and like next year we see the change. But then on the other hand, like there was these decisions from Finnish government, for example, there has been quite strong support for research. So now it's good time to invest for the future.
Thanks, Tarja.
Thank you very much, Tarja. And I would like to apologize once again for the bad connection. Thank you, Juha, for your patience for joining us here in this session. Now we're moving forward further on to start focusing on universities and their role in bringing innovators and innovations to the market. What skill sets should the graduates have to be able to thrive in the raw materials sector? Our first speaker here today is Riina Salmimies. Very much welcome. You are Dean at the Lappeenranta University of Technology, and we are very glad to have you here joining us today. If you have any questions to Riina or the other speakers that will follow, please write your comments and questions in the field close to the screen that you're looking at right now. Thank you, Riina.
Thank you very much, Mia. Thanks for enabling me to join as well here in the studio. I have 10 minutes, so I will take you through one of the stories that we've worked together with EIT RawMaterials. So these educational talks will now focus on capabilities and skills that graduates should have in order for us to make the Green Deal happen and for us to sort of enable a more sustainable European raw materials sector. Something that I think was also evident in the introduction was that the European Green Deal is not only about the change or the transformation of the energy sector, although that has been very much in the focus, especially in public discussions. But if we look at the various goals or various activities over the course of several years in the Green Deal, we understand that it's also about this planet, this Earth that we live on, and there are multiple aspects of biodiversity as well as sustainable use of raw materials. So how to develop that, especially in the European raw materials sector, is quite important for the educational sector as well, and for the graduates when we educate them on various technical aspects, but also with respect to their attitudes. What kind of professionals will they become as they enter the job market? You probably all know that the OECD has predicted the doubling of raw material consumption by 2060, and we obviously need to discuss whether this is a threat or an opportunity for the industry. I think it's rather both, because there are multiple paths of substitution, of course, multiple paths of more efficient raw material consumption, but we also have to be very mindful that as global population grows, the Earth might not suffice. So we might not have enough raw materials in order to satisfy the growth that we have in the developing countries, especially, but also in Western countries. We are talking about the electrification of the transport sector, which will require significant raw materials, and we have to somehow respond to that global and also local demand. There's a lot of talk about not having a planet B, but we do have to ask ourselves the question, would it be necessary? It might be necessary in the distant future for us to consider interplanetary supply chains, space mining, and other activities that are beyond the scope of what we are currently looking at. But how should then the educational sector respond to these changes, these demands? The technical content is still significant. The fundamental engineering skills and knowledge, they are still the basis of all the education that we do in technical universities. That might not be sexy, but it's still quite critical. And very often when we talk about development of new skills and new abilities, we forget that there's still the very core. We need our engineers to be very capable in terms of technical aspects. But in order for the raw material sector to respond to a changing world, we need to educate people not through learning facts by heart, but rather through attitudes. The entrepreneurial capacity that people need to have has to be developed during education as well, and that is something that the educational sector has to respond to. These are then people who question things, they envision alternative futures, alternative paths for us to take, and this is more a matter of cognitive capabilities rather than the technical content. The technical content is still very relevant, and we are doing the right things, but we need to consider the methods by which we educate in order for us to educate the kind of people that we need to do these things that are required for our future. It's also very important through continuous learning, of course, to educate people to learn new things. So not to think that for 20 or 30 years things will remain unchanged, but rather be able to learn about digital solutions, for example, and develop new things within the sector, discuss with people from other sectors. So for example, when we look at digital solutions, very often we have to work with software engineers. But if we don't understand their world at all, it's very difficult because we talk in completely different languages, and very often the solutions that we developed are not current. But in short, the development of entrepreneurial capabilities and capacity is extremely important for the raw materials sector and for those gaining a higher education. Then there are a few case studies that I would like to highlight that have been funded by EIT RawMaterials, where we are focusing especially on these capabilities within our graduates. We have a master's level course that we've been running for a few years now, where we focus on business cases. So we have engineering students from various fields, and they together with the business students solve business cases. So we have technical problems, but we are not solving it from a technical aspect only, but also looking at the business case. So how to make a profitable business out of what we are trying to solve. This very often can deal with, for example, byproducts, waste materials, and we all know that it's not really easy to make a sustainable business or a profitable business out of waste materials. We've done this in collaboration with several European universities and are very thankful for the funding that EIT RawMaterials has provided for us. And all together for the past 2 years, roughly 120 participants have gone through this course. It has been highly popular within our university, and I think it is because of the business cases. So rather than doing technical content, we do business cases where we have several engineering disciplines. What is also very nice is that it's 50-50 in terms of male and female participants. So we're not only looking at male participants on those courses, but also female participation, and that is very important for the diversity of the raw materials sector. What we are now currently developing is to seek to feed the EIT Jumpstarter in order for us to get spin-offs as well out of the master's program, or sorry, the course. We have another case where we are doing a triple degree program together with our partner in Germany, with TU Freiburg, and with our SA partners in Europe. And there the focus is pretty much on entrepreneurial capabilities in the raw materials sector. So we have entrepreneurial content and we have raw materials content within the different universities where the students then study. I'm very excited about this, and I know we have other developments as well in terms of degree programs where we combine the technical content and the entrepreneurial capabilities as well. The first cohort here started a year ago, so we will soon be seeing the first graduates. Last but not least, I would like to invite you to join a few of the developments that are ongoing. So we have a virtual workshop upcoming, organized by LUT University, and this is part of our MATEAM project, where we are developing yet another master's program dealing with entrepreneurship, innovation, and technology integration for the mining sector, and this is starting in 2023. We also have a digital educational hack coming up, organized by LUT University, and here we are getting the business cases or the hacks from 3 different companies, which are Sandvik Mining and Construction, Mevea, and Process Genius. And if you are interested in joining this, I would encourage you to contact our coordinator, Matti Lampinen. You can see his email address here. This is all I have for today. Thank you very much for the opportunity.
Thank you very much, Riina, for joining us here today. As I've said earlier during this event, we are doing a hybrid here together today, where we have half of the speakers, about 7 persons, plus Olli and myself here on the spot and at the event. And then we also have 7 or 8 speakers joining us from different parts of the Nordic countries and Baltic countries. The next speaker is actually joining us online from Tallinn, Estonia. His name is Professor Michael Hitch, and he is with us online from Tallinn, where he is leading the Institute of Geology at Taltech University. He is also a member of the executive board of EIT RawMaterials. And Michael, he will focus especially on mining education and the changes ahead. Welcome, Michael. We can't hear you, Michael. Could you check your microphone? It looks like it's muted. And we would like you to share yours. Thank you. Now we can hear your voice. Could you also share the presentation with us?
It should be shared.
Unfortunately, we can't see it right now. And I know you have a lot of good things to say.
Can you see it now?
No.
God, I hate technology.
Yeah, let's put it this way. We don't like technology when it doesn't work for us. Meanwhile, okay, here it is. Now we can see it.
Oh, okay. I'm burning my 10 minutes, and you know what?
No, it's okay. The floor is yours, Michael.
It's impossible for an academic to talk about anything, including describing their breakfast in 10 minutes. So what I'm going to try to do here, and again, perhaps my presentation should have been put in front of my colleague who just went, because really what I'm going to talk about is mining education kind of at the 30,000 foot level, and perhaps a bit more at a theoretical level on some thoughts about things we have to consider. I think all of us in our university, those of us who went to university or college, have had those experiences where you've had the professor that sort of stands in front of either a PowerPoint or an overhead transparency or something, or a chalkboard even, and basically drones on. And I think those days, we talk about how we need to teach in the future. And yes, we've come up with fancier tools on delivery, but I'm not sure the actual pedagogy and how we get the information across has really changed. So I'm suggesting in this presentation some ideas on how that might work. First of all, we're all very aware of how our society has changed. It's become very interconnected. It's interesting that, global society today, about 55% or even greater now of the world's population is connected by the internet, as opposed to back in '95, less than 1%. And the way that we're looking at knowledge transfer is emerging at a remarkably quick rate. Again, it's not necessarily the toys and tools, but it's actually how we're learning and how we're taking some of this knowledge and experience on board. And I've kind of created these three words called education without borders. And I think that's really the reality that we're facing today. In the minerals sector, we're looking at different types of innovation and creativity in terms of how we're developing, moving information back and forth, and definitely taking steps beyond traditional methods. In mining, for example, and mineral processing, and really in other sectors as well, certainly in the manufacturing sector, that we've had this explosion of cheap sensor technology and fast, intranets and local area nets for communications. So we can move large sets of data and information and real-time data back and forth really, really quickly. And now with the advent of supercomputing and very high-powered computing available even at your desktop and arguably even in your hand, it allows us for lots of different opportunities for visualization and then ultimately simulation using these large sets of data. The next phase, I suppose, in terms of how our industry is going to move forward is, again, a lot more remote control, a lot more automation, a lot more mechatronics, and certainly robotics and autonomy. And we see this in other jurisdictions. For example, in Australia, we now have completely autonomous ore trains in Western Australia moving iron ore from the mines to the port. We now have autonomous haulage systems with trucks. And I know in Sweden, with one of the partners, Epiroc, they're moving towards more autonomous mining equipment. There are challenges, and I'm kind of not so much a technocratic person, but I try to see things in a bit of a 360 degree way. But there is a cost of digitalization. There's a social cost. For example, we're redefining what social license is. We're redefining what that social contract is between the mining operator and the community. We're also looking at the change of work. Full-time jobs may not necessarily be the way of the future in our sector. We're certainly looking towards more of a gig economy, as they refer to it. We also have to be mindful and more respectful of diversity, but also resilience and quality of life. Things are changing. And I think we've seen that over the last 6 months, perhaps, with our little friend that came to visit. But our life has changed, but yet life goes on, but just differently. But we also have to share what I refer to this value paradigm in the advance of technological innovation. For example, if a mine comes into your local community and is fully autonomous, what are the job opportunities? What is the value proposition to the community? So again, we have to be aware of this. Oops. We're also seeing mining operations changing. They're becoming very, very segmented. And we're seeing what's referred to as the MET sector, or the mining engineering, technology and supply sector, booming. These are subcontractors and contractors that are effectively running units of your mining operation. So ultimately, traditional mining companies basically just become super project managers. Diversity is an essential element of that social sustainability and social license component. And as technology advances, we have to continue, and particularly as we're dealing with young people, because we're all well aware that they're slightly different, we have to create engaging workplaces and places where people feel respected, valued, and connected. And again, to some extent, this is a bit of a change of a mindset at a mining site. In terms of diversity, and I look beyond gender in terms of diversity, but I look at diversity in the sense that you have a set of different ideas and different ways of looking at a problem. And it's a magical thing when you can get a group of people around a table, and we see this with hackathons and so forth, that we see the product of a remarkable amount of creativity. And this is something that we really need to be mindful of. And finally, the idea of attraction and retention of people that want to come into the mining or mineral sector. That, again, the days of, what were the 3 Ds? Dark, dirty, and dangerous, right? There still is a public perception that's what mining does. And I know that we spend millions of euros and dollars on trying to reposition the narrative or portray mining as something that's technologically advanced, something that's ecologically mindful, and something that respects local communities. And this is something that we have to continue to push, and it's going to become even more imperative as technology becomes more prominent in our sectors. Industry, this is, these comments come from conversations with the big orange company in Australia. These are real things that industry feels, that academia has, and certainly mining education, is focused too much on management skills. And they've taken the eyes off the technical skills. And they see that this pipeline of technological knowledge is starting to become very broken and very segmented. And there's a need to kind of reinforce the technical basics. That being said, they're also looking for generalists. They're looking for people that are not necessarily just drill and blast engineers or mineral processors, but they're looking for people that can move from one station to another a little bit more seamlessly. The view of industry is that universities have sacrificed quality of education for quantity, bums in seats. And we are seeing that at the federal level in many jurisdictions, that the amount of funding going to universities is decreasing. So there's a greater reliance on commodifying education to some extent. Industry is also looking for more field work and exposure. They're looking for greater softer skills. Can you work in a team? Can you communicate? And this is particularly challenging with some of our newer, our younger people that are more dependent on communication devices, phones, etc., where some of those traditional communication skills and teamwork skills need to be developed. And also we need these tech solutions to be in harmony with zero harm workplace solutions. So there's a demand for, we need to stimulate the demand for mining programs and enrollment. We need to address the resource sector shortages. We need to encourage ways to cross-skill, reskill, upskill the workforce with a digital mindset. We need to look at research and innovation to be able to provide solutions. And also, we need to influence public policy and technology in the terms of future work. So how do we teach this stuff? How do we take all of these ideas and put them into programming? First of all, we move to data-driven. We need to look at developing these higher analytical skills in our students. One way of doing that is working with real-world data that illustrates those core principles that we, the traditional professors, want to, the word is inculcate, or just to sort of stuff into our students' minds. But we also need the real-world data to make that learning and those learning outcomes and learning objectives very real and tangible. We also need to take this idea of team-based learning to a completely new level, something called co-learning, where the students are learning from each other, as opposed to just working on projects in teams. And this is one of those things that kind of develops and fosters the diversity mindset. How do we deliver the courses? What is kind of my vision for delivery? Well, one of them is working in teams, but on, as I said, on real data sets. So here you've got an example on the, I guess it would be image left, would be you have groups of master's students that are working on a specific problem. So the professor is wandering back and forth between groups, basically acting as a mentor or acting as a guide. So no longer chalk and talk or standing there in front of a PowerPoint, which I'm about to do in about an hour. But here you've got an example of how you co-learn from people. And these students, in this case, are students that come from industry that are doing a master's program. So they bring all this interesting information. Up in the upper right-hand corner, you've got the AR Mining Sandbox, which is one of our projects here at Caltech, where we're using augmented reality to demonstrate geologic principles. And finally, Meyer Books, which is EIT. I would, because I'm involved, I would call it a flagship project, but certainly a very large augmented reality, VR or virtual reality concept where we're developing a virtual or a mixed reality textbook for mining and engineering education, where you would have a physical document, but you would have targets, which once you put on a device, whether a headset or use your mobile phone, you can deep dive into certain topics and take advantage of simulations, in-world experiences, etc. It's very cool. We need flexible learning environments. We need, we know that there's a demographic shift. We have lots more mature students. We have students with full-time jobs and families and lots of international. And we can just put COVID-19 in there just for grins, because again, we're shifting how we're delivering our material. Our students have different expectations. That there's an emphasis on job preparation, and they're more interested in self-directed experiences. And this is kind of an interesting point, and these are sort of the magic words about how we need to consider education, university education going forward, is pace. We need to develop flexibility in our teaching that encompasses accelerated or decelerated learning, basically on the basis of, of how the student is learning, whether the material is more difficult or more conceptual in nature, what have you. Place, location, where are we going to do it? In a classroom, in a home? Are you going to be sitting on a bus? Or are you going to be sitting in a mine site taking this course material? And finally, how we deliver it. Whether we deliver it fully online, blended, or something else using enhanced experiences. Big part of this thing, and this kind of goes back, and I want to kind of tie it back to what's going on with EIT and EIT RawMaterials Academy. I cannot say enough about the RawMaterials Academy. I think it's a remarkable program, so rich, and I've never ever seen anything like it in my experience. That it's all about collaborative teaching and learning. It's about linking other universities and other entities together. For example, in the circle here, you've got Taltech that works with Epiroc, with Outotec, with a Polish mining company, KGHM, European Goldfields, our friends in Finland, and with EIT itself. And what this does is it creates a very rich, multi-dimensional, very diverse learning opportunity for our students. At the top, you have what's becoming more common, particularly in Europe, is the collaborative learning agreements. And this is an agreement that we're in the process of working on between ourselves, with our friends in Leoben, and with TU Freiburg. So what we're seeing here is that we're looking at much greater linking of resources, linking of talents, and linking of experiences going forward. So what we need to do is to extend the university's reach, not only into society at large, but also into industry. And there's always been this kind of suspicion between the two groups of industry and universities. We have to focus on lifelong learning. And again, we heard about this just in the presentation before mine. It's all about cross-skilling, upskilling, and reskilling. Things are changing, and things are changing fast, and we have to be prepared to learn and unlearn very, very quickly. And we need to teach the capacity to do this to our students. For example, developing certificates in mining studies programming, where we'll take people that are not necessarily technical, but teach them about natural resource development and mining and mineral processing, and give them some micro-credentialing opportunities. And again, developing corporate learning products. So that would be a great example for EIT, is they could develop certificates and individual corporate learning opportunities for member organizations. I think that's about my 10 minutes, probably more, but I want to thank you very much for your attention and your patience.
Thank you very much, Michael. This was a very interesting presentation, and I will ask you to stay put online, because we have questions for you and also for Riina. But first, I'll give the floor to our next speaker. He's also joining us online, although he's here in the south of Finland, representing Aalto University. Professor Jari Koskinen, welcome. We will, I hope that, could you please try to unmute yourself? It will be easier to hear you. Yes.
Yes, thank you. Okay, I must apologize, I cannot attend this wonderful meeting. It happens at the academic year with all the teaching responsibilities. I could not hand over this big responsibility to our students in the university, so you hopefully understand that. But this is what I'm telling you about in this talk. How do we educate? How do we use EIT RawMaterials to benefit our education? And
excuse me, Jari, it seems like you're muted again. Could you check?
And I also somehow, I don't know what to do, but let me try once more.
Yes.
So,
it looks
online.
Good.
So we educate innovative people that can make change in this world, and the strategy of Aalto, and I guess all the players in the world, is that we have to create some change. We cannot continue linearly. It's in the strategy of EIT RawMaterials as well. We need to make sure that there is a sustainable future for us and for our next generations. We need these students to be able to do that. EIT RawMaterials helps us to attract good students. It's one of the basic issues We will rely very much on entrepreneurial education. We can offer our partners universities a portfolio for students. We induce more industrial collaboration, and we can offer double degrees and international studies for students, and strengthen the university networks in Europe. So this was introduced already, Raw Materials Academy with its components. What do we have there in particular? We have, I will show you some examples, but we do have some wider society learning activities. Particularly proud we are about the labeled master's programs and PhD education and some life learning. So let me just briefly visit some of the examples. The wider society project is with several partners, and we visit high schools and young people to explain what is the opportunity to make a change in this world by studying chemistry and material science in that field. Master's education, well, labeled programs are highly important with this, as explained in the previous talk as well. Our highlights there would be this AMIS program, Advanced Materials for Innovative and Sustainability, Innovation and Sustainability. It's jointly with Grenoble, Darmstadt, Bordeaux, and Liège universities. It has several students. We are looking at in Aalto in stable conditions, something like 20 students. This COVID has an implication to it, but I guess we can struggle over that. The other that is more from our traditions is this metals processing system. So circular economy, entrepreneurship. Okay, there was another level program as well, European mining program. It's not explained here in more detail, but then we are proud of our PhD education programs, CSIMP. And again, we have a number of partners shown here. And lifelong learning, we are part in this 3D accelerator for 3D metal printing, again, with several players in Europe, including industry. That's something, a technology that we need to educate to people that are already, let's say, have an engineering education, but we can definitely introduce them new technologies. And this is one way of doing it in lifelong learning projects. So this is one of them. I could not overemphasize in Aalto particularly that we have a very strong ventures entrepreneurial education system. It is composed of the Aalto Ventures program that provides teaching. So there's a number of professionals available there. We have the Aalto Design Factory, which is a big project for learning product design, interdisciplinary action with students. A-Grid, so we have in the campus now a vastly increasing number of startup companies. And then, of course, we have the student initiated activities, foremost Slush, which for the first time is now skipped because of the COVID. Hopefully next year it would be there available for all of us. And Aalto Ventures program, it's accessible to all students at Aalto, lots of courses, and it's interacting in very closely to our EIT RawMaterials courses and so forth. And I think one of the, I would not go to the details, but this is an example what they can provide in courses, the Aalto Startup Minor. These courses are widely used applied in our labeled program curriculum. So I would summarize that we can combine the strategies for sustainable future. It's very much underlined strategy for Aalto University right now. The new strategy, which will be effective beginning of next year. Innovation and entrepreneurship is of course the stronghold, and it's supported by it's an integral part of all our projects at EIT RawMaterials, and of course the collaboration. This is one of the largest EIT kicks this raw materials, so we have a good consortium here. That's what I have in mind. Thank you.
Thank you very much, Jari. We are very happy to have you with us here today. And Riina, you have joined me back on stage again. Very much welcome. Now, Michael, Jari, and Riina, we have a few questions for you regarding the future of the universities and the collaboration within the EIT RawMaterials. But first, I would like to ask you, how do you see, what are the most important things that you see we will need to change after this COVID has passed away?
Okay, tough question.
Yes.
Well, I think there are a lot of changes already taking place because we've had to restructure the way that we educate people, and we are now currently with the heads of the degree programs looking at what is then the post-COVID, and most likely we will see an increase in online education, but that has already been the direction where the world is more or less moving, because we want to make education globally available, as we see that as the sort of the prime tool in order for us to advance the state of the world, to say so, to less prejudice and more collaboration globally. But that's a rather difficult question. Continuous learning is something that is developing, but it's not because of the COVID situation. So I'm not really sure if the COVID changes a lot of things, but we've already considered these before. So, but maybe Michael or Jari would have different views on this.
I can maybe make a comment. You know, it's funny that, you know, I think it was probably 10 years ago that, you know, it was strongly suggested by our educational support teams and our people, boy, you might want to consider, you know, we've got this really cool way of putting courses online and MOOCs and all these things that were all kind of, you know, new and fantastic. And, you know, those of us that are a little grayer, we're kind of going, you know what, I don't have time to make these changes. And you know what, I'm happy with the way, and my students love the way that I stand in front of the classroom and talk and all that sort of business. And it's absolutely amazing that, you know, I watched this sort of terror take place in March and April of this year, where all of a sudden we were told, got to go online. And it was amazing to see how a lot of the more senior professors really embraced this and kind of said, hey, this isn't so bad after all. So I kind of agree that we're going to be looking at a more hybridized model going forward. I think that we've learned to use technology a little bit better, and not entirely, because we still can't unmute ourselves, but I think we're moving forward. And, you know, we're our friends in Finland, for example, are starting to use virtual reality for mineral identification labs, which is a pretty remarkable thing when it's a very tangible, very much an eyeball-brain connection thing. So, you know, I'm looking at it very optimistically. And yes, it's kind of ugly and uncomfortable, but I think what it's done is kicked us in the pants to actually start being more forward-thinking about how we're teaching.
Yeah, well, what has to be changed? Well, COVID induced this online, but it would have never done that if we didn't have the tools already. So it's maybe a coincidence, and I think it will be actually adopted to some extent. I must say that yesterday, for instance, we had a lecture where we could invite specialists all over to a lecture. It would not be possible if we would invite them to, let's say, join by flying and taking a hotel and spending 2 days for this. Impossible. Now it's suddenly 2 hours discussion was possible just like that. So it offers us huge possibilities. What is the real problem? Is it this is unreal? We don't know how the students actually feel. We don't have a direct contact to them. We have to develop means to contact them. Otherwise, maybe I have to learn to use Facebook or something. I don't know, but we have to have means to get a feel of what they are doing, so that the well-being is secured and the education will continue. So that's what is missing.
Would you like to continue?
No, just maybe to add to what Jari was saying. So from the perspective of science, so we used to organize seminars for 10 or 15 people, and now the world is fully open because we're using online tools. And suddenly you can, follow up on a webinar where you have Nobel Prize winners and laureates, where 3,000 people attend and can actually gain this insight from them. So from the perspective of science, this is an immense opportunity. But I agree with Jari that this sort of community feel that develops within student communities, this has been hampered by the COVID situation, and student communities have had to find new ways of organizing events, for example, in order to embrace this first year experience and develop those social networks. So that is something where we've had to find new ways of operating.
But the students do it the same way as traditionally. They are very active in meetings, so that bears some risks as well. But yeah.
Would you like to add on that, Michael?
No, I mean,
you managed to mute yourself. I won't tell anybody. We're working, we're learning.
I think of it as called the democratization of knowledge. And I think that that's a wonderful thing, that all of a sudden, everybody can have the knowledge now. Everybody has access to them. It's going to be interesting how it's going to shake up traditional university administrative structures, though. Do you pay the same amount for tuition for an online course as you do for a face-to-face? I mean, that was one of the questions in The Economist this week about Harvard. Do you pay $55,000 a year for tuition on distance learning? So the value proposition, again, changes a little bit. So we have to be clever.
Yeah, that's a real question, yeah.
But that's really an opportunity for us, for the Finnish universities, for example. So when we see a decline of number of students in, for example, universities in the United States, then that is an opportunity for us. So let's capitalize on that.
Yeah, how can we improve the innovation capacity in our higher education institutions? What kind of trends do you see on that?
I think we've heard about it in terms of the entrepreneurial training of our students. That our students are really bright. I mean, there was a young lad that came in to the office, my office, a couple of days ago. That what he's doing is he's taking mine waste and blending it with raw recycled plastic, and producing a durable plastic that's got up to 30% mine waste contained in it. So, and this was a first-year master's student that's kind of coming up with these ideas. So I think what we need to do is to do a better job at helping them find ways and pathways. And again, EIT and their Jumpstart programming and the Academy programming is a wonderful platform to help take these young people and to sort of help grow and blossom and mentor them through the commercialization of some of these ideas.
And maybe to add to what Michael was actually already talking about in his presentation, so highlighting these digital solutions and the leap that we can actually take by employing digital tools. But to be very honest, it has been a little bit of a difficulty to get software engineers and raw material experts to work together on things when there's a lot of history of, for example, software engineers working with healthcare problems and things like this. So to get them together to develop those digital solutions is very important. I've been very happy to see this development with the Copernicus data within the EIT RawMaterials. I think that's an amazing direction, and it was actually one of the examples that we have on this very introductory low-level course on digital solutions for the raw materials sector. But to get people into this, to understand what are the opportunities, the solutions, and then maybe go deeper into developing programming skills or something like this. So I think that is something that needs to change in order for us to implement digital solutions fully in the raw materials sector.
Olli, I can see that you have a question.
Yeah, so there was on one of the online chat remarks, it was actually quite a provocative remark, and it has to do with this innovation capacity and an observation that universities in general, without with few exceptions, they are not that good at commercializing innovation. So innovations are not going to the market from the universities. What would need to be changed? What kind of change do you guys need so that that would happen? What would you say?
I think that's a great question, and I think there's still the question of does something need to change, because obviously this collaboration with industry is very important, because universities are not commercial actors. So rather the companies are the commercial actors, and that's why we have upscaling projects where we have industry leads and all this, and universities have their role to play in that. But for example, at LUT, I think we have the highest number of commercialization projects funded by Business Finland within the Finnish universities when we consider the size of the university, obviously. But those have been traditionally, for example, from the energy sector, where they've had this very tight industrial collaboration, and the needs are very clear to the university. Sometimes when we have discussions with industrial counterparts, there are issues of trust. So whether to communicate the actual needs, the strategically important things. So that has to develop further. But universities, they have an academic task to fulfill, and the science is very important, and we need to promote that globally as well. So it's a little bit of a balancing act. So I wouldn't say that things are that poor, but sure, we can do better.
Yeah, I agree. There's many ways of progressing. I think we indeed do have some financing opportunities that can boost innovation also in research, and our, let's say, basically they would be our doctoral students that are involved in industrial cases, and innovation follows. There are patents launched in this together with PhD work at higher numbers. And of course, I think universities' main message is to educate, to do research and educate people, so these people then go to the society and should be able to do innovation there also. So then I go back to this entrepreneurial education and tools.
Michael, would you like to add to that?
I think that scares academics, and I won't say all academics because it's a huge generalization, but it's a lot of it has to do with IP, and it depends on how innovative, to overuse that word, but how flexible your academic institutions are with IP, and how that IP is going to translate through into that commercialization process. You know, for a lot of academics, the thing that they're taking forward is their baby, and it's real hard to hand your baby over to, you know, an angel investor that's going to basically take 75% of it from you, right, or more. So we have to think about how we construct that bond between the inventor and the commercialization process, because it's a very harrowing and kind of an uncomfortable experience. And it all comes down to how that IP is managed between the university, the inventor, and the ultimate startup company, for example.
Yes, if you would only allow me to dream a little bit in this sense. So we have to understand that the Finnish universities are very strongly guided by the Ministry of Education and Culture, and there are specific performance indicators that the universities have to satisfy in order to secure their fundamental funding. And this tends to drive us towards specific processes. So if you were to give me, 50 million euros every single year without the ministry funding being necessary, then maybe we would venture onto things that are maybe a little bit more risky, a little bit more unsure, uncertain. But that fundamental funding has to be secured in order for us to be adventurous. I love innovation. I think, spin-offs and new companies, new business, that's great, and we have to allow it to grow, as Michael said. But it is difficult with the constraints that we have also within the national scheme.
Thank you very much for this. It was a very interesting debate. For those of you who would like to know more, you'll find more information about this on EIT RawMaterials.eu. Thank you very much. Now we will go forward to the fourth and last session of this event here. If you have any comments or questions, please add them in the chat box close to this screen, the window. And we will continue to talk about scale-ups and innovations and how to support new businesses in raw materials field. With us, we have 5 successful projects that we have been working with here at the Innovation Hub Baltic Sea. And first out to present is Lauri Uotinen from Fractuscan. Hi, Lauri. Can you hear us?
Yes, loud and clear.
Yes, and you have not muted your microphone. Well done.
Not yet.
The floor is yours.
Okay, thank you. So first of all, thanks for this opportunity to present Fractuscan. And actually there was a excellent introduction to my background in the previous panel discussion. So I have been confronted by this question myself 3 times to this date, that whether to commercialize or not to commercialize. And then from the point of researcher, this question is more about that it kind of leads you to the kind of entrepreneur career, whereas you are aiming to be on a more academic career. So the incentive for the researcher is not so strong. And in my case, the first commercialization occurred due to necessity. So I was running out of funding. And actually, that was Fractuscan. So I'm going to talk about that in a moment. And then I thank Michael for introducing our research. So we're currently engaged in heavily in the usage of VR in education, and this mineral identification project is actually my research, so thanks for the soft ad. Okay, let's go into the topic of Fractuscan, which is a commercialization project based on research and received the EIT SME booster. So what problem Fractuscan addresses for the clients, which are mines, and especially open pit mines, is that these slope failures in all of their forms is always a risk for safety and interrupts production. And right now, the only way to deal with this problem is through manual subjective stability assessment. This is basically a rock engineering guy or rock mechanics who goes to the site and then makes a simplification of the geometry, numerical modeling, or empirical methods. It's all very slow process, and it's dangerous work. You have to go very close to the rock walls, so you are under risk of getting injured yourself. And considering the size of the site, it's also very hard to cover the entire area, so you rely on your gut feeling to identify most risky locations. So as we all know, drones have been taking over this part, and what Fractuscan is offering as a solution is we train the mine crew to fly drones in a specific way. They basically take photographs, as is illustrated in the second picture, and then we use photogrammetry, which is kind of complex extension of triangulation to recreate a digital twin of the mine. This results in the middle picture, which then gives us like a three-dimensional high-resolution representation of the customer mine. This is then used to analyze where risks may occur. This is basically where sliding blocks on falling blocks, rockfall can occur. And then there's the risk treatment part. This resembles the traditional, but it's more like objective and covers the entire mine instead of just some specific targeted location. So this basically means that we are COVID-19 compatible. So we are not traveling to the customer mine, but instead the customer mine is sending us the photographs, and we pick it up from there. We create the model, make risk analysis and risk treatment, and this is sent back to the mine. So we are a team of 5, and 2 of us have a PhD, and Martina, our CEO, has a quadruple master. So this is from the EIT labeled European mining course. And Henry is working hard to finish his master, and he's an excellent drone pilot. And then we had Emilia as a business designer, but she moved, so we are now looking for a business developer. And this remote scanning is taking over quite quickly. So we see a yearly growth rate of like 20%, and there are thousands of mines active right now, which can be targeted. And there are also underground mines where this technology also works in a slightly different way. And this leads to us building up sales. So we established in December 2018, and then received our SME booster from EIT in 2019. And now we are in 2020 and in the sales ramp up stage. And we have been looking into multiple directions. So we have also like a strong business coming from rockfall risk to highways, which is a similar problem with what the mines have. And here we cooperate with the Geological Survey of Finland, GTK, and Sure, which is like a real estate consulting startup. Now, COVID, of course, has a negative impact on the business. So it completely eliminates traveling, and we need longer times. We can't like work closely, and pilot training is harder. Also, networking opportunities are harder and harder to make the first sale. However, there are also some positives. For example, now this remote operation mode is actually basically the only mode what you can do. So this remote inspection, where you don't have to have external persons coming at your mine, but they can just inspect the mine remotely, is a good model. It also leads to lower costs, and it's completely safe. So the only device that can get hurt is the drone itself, and they are replaceable. humans are not. Now, I would like to take the opportunity to seek out partners and advisors. This, I believe, is the whole point of the EIT network. So if you know some mind that is struggling with stability issues, then please do let us know. And then we are always open to ideas on how to accelerate the scale-up process. So you could become an advisor to us. And then if you're just interested in our technology, how it works, or any other question, then just please contact us and we can tell you more.
Thank you very much, Lauri Uottinen. This was a very nice presentation, and I really like the way you presented it, that you have been affected in a somewhat positive way by the COVID-19 because of the remote working. We have 4 really interesting upskilling projects with us here today before we finish. And with me here, I have Donat Ponamariov from Vietso. This floor is yours.
Thank you. Hello, everyone. My name is Donat. I represent Vietso. So I'm going to present our startup, what we do, and how the raw materials is supporting us. So we're based in Vilnius, in Lithuania, and we're developing vibration energy harvesting technology, which is basically capable of converting vibrations into usable electricity. And the mean of that is to power the wireless IoT sensors in the industry and making them living a long and healthy life. So currently, almost all of the wireless sensors in the industry, deployed wireless sensors, are powered within the help of batteries, which seems like a good thing. However, those batteries have a lifetime, which is approximately 5 years there. So it means that after 5 years, those batteries will have to be changed manually by a human being, and that really costs a lot. It is calculated that to change just one sensor's battery, it costs approximately 150 euros per unit. And since there are usually a lot of, like hundreds of sensors installed in the industry, so that adds up a major cost for the sensor owner, and that process basically repeats every 5 years. And one more thing is that manufacturing of the batteries carries a terrible impact on the environment of Earth, and for someone it's more important, for someone it's not that important, but we have to mention that. So how do we tackle that? We do a source of renewable energy, which can make the sensor solution become absolutely fit and forget in the industry. It means that you just install it and you forget about it because it can live as long as you can think of, and therefore it can make you save a lot of money, which would arrive if the sensor would be installed within the battery. And in general, it creates a significant value for all the supply chain in the industrial IoT. The real beauty of what we do is that we're yet the first and the only ones in the world yet commercializing the vibration energy harvesting within one particular material, which is the piezoelectric polymer thin film named PVDF. And prior our inception, it was absolutely no one believed that this material could be good at energy harvesting. And that can be backed by the fact that right now we're having approximately 30 times more energy from that material compared to any other scientists with their experiments in their lab. So basically, we're leading the world within the possible power output with that material. And the international PCT patent of our developed design is already pending, and we are looking forward to file more and more, basically a cloud of patents. Definitely there are a few startups in Europe which are doing the vibration energy harvesting as well, however on somewhat different technology, which is named the electromagnetic induction. And this technology has some major disadvantages because it is approximately 3 times more expensive. Heavy metals are used there. The manufacturing process of it is much more complicated. So when you put everything in general, it makes an obvious choice to use the piezoelectric piezoelectric solution developed by us. However, vibration energy harvesting is a technology which is absolutely new in the industry, and it has a lot of potential. It will be discovered very, very soon. So this as well can be backed by the fact that one of our competitors just a few weeks ago got acquired by Hitachi Vantara, and that means a lot. That's a good signal for the industry, I guess. And despite the fact that our core product is the vibration energy harvester, we're stepping into the sensor market by developing the autonomous wireless sensor within the already implemented energy harvester inside. So we're going with the turnkey product in the industry. After building a pipeline of almost 1,000 leads in our CRM and talking to most of them, we have identified that energy harvesting is a very, very interesting solution for everyone. However, everyone is not eager to do the implementation work of separate parts like energy harvester together with their sensor. So that's why we needed to turn that way and to develop this solution. And that is exactly where the EIT RawMaterials is helping us, because with their help we're developing exactly that autonomous sensor solution. And the prototype of this product shall arrive in the middle of October this year, so basically in a month. And we have already a number of leads who would like to try it out as soon as it is available for sale. And yeah, we hope to crash some sales with it, and we'll see how it goes. Anyway, already 15 companies worldwide have purchased our development kits, which we already have with our vibration energy harvester, including some big names like Singapore Telecom, SKF Group, Siemens. And we have completed the Startup Hub Poland accelerator. We have been through the Expreneurs accelerator in Munich. We have almost barely made it to 500 startups accelerator in the Bay Area. And in June we have raised our pre-seed round of 180,000 euros, and we look to raise the next round in March 2021. So if this technology is interesting, and if we're looking for smart money, so if you could help us with this, we would love to talk. And right now we're a team of 4. However, due to the support of the raw materials, we're capable of hiring more and more people. So till the end of the year, we should be a team of 8. And yeah, if you consider yourself as a great mechanical or electronics engineer and you would love to join, feel free to give me a note. And we're also working within the local technical university, which we're subcontracting now, and they're helping to push our technology forward. So that's all from me. Thank you very much, and look forward to talk to you guys.
Thank you very much, Donat, and you will be able to read more about also your business on our website, EIT RawMaterials.eu. Thank you. Hi, Marina, welcome. Marina Petrichenko is our next speaker for today. She will present her company, 3D Strong.
Good afternoon, ladies and gentlemen. My name is Marina Petrichenko. I'm co-founder and CEO of 3D Strong company from Latvia. We produce special additives based on carbon nanotubes, which can increase mechanical strength and durability of existing 3D printing material up to 5 times. The main problem of 3D printing industry is low mechanical strength and durability of existing material. Actually, only prototyping is possible from these materials, and only prototyping is applicable for this kind of the materials. But our company develops special solutions for all three types of 3D printing materials, such as liquids, filaments, and powder. And we can increase the strength of material. Minimum starts from 200% till 340%, and we also can increase durability up to 4 times. It's allowed to print real things for real use from these current materials. This is really, let's say, value for the industries, because we can apply our technologies to any kind of industries such as automotive, aerospace, or healthcare. We can provide additives which can allow to print the parts for the drones, for example, from the liquid polymers or from the filaments. Also, we can increase the durability and strength of the inners for the cars. And this opened for this industry such a good opportunity to increase the market size for the 3D printing industries, because currently it's just 16 billion euros, but it's really estimated to grow for the next 4 years. It could be about 40 billion euros. Our business model for our company, we're selling not only additives based on carbon nanotubes, but also we are provided a special solution for the business. We are developing technologies for 3D printing materials. And for the next 2 years, we're really planning to build the mass production of our materials and increase the value of our facilities. Thanks actually to the EIT RawMaterials, with a huge network, we already found a lot of industrial partners with whom we're tested our technologies, and currently we're planning to run 6 different pilot projects with producers of filaments in Europe and the producers of liquid polymers. And we already received the first pre-order of our materials for the 24 kilograms of our additives in the first year, and this year we hope that we'll start to generate our first revenues. Of course, we met some obstacles in this, let's say, this way to creation of our technologies and to creation of our companies, and for us it was a bit challenging to make this company which based on deep tech technologies, because it's real science. It's just not like easy product to develop and start selling on the market. And sometimes the market's not ready for the real innovations, but we are trying to educate our partners and actually industry to make to find the great solution for the existing materials and for the existing products. And also we're helping to find the final end application for our partners. And currently we're a company which established company which produce special additives, which develop special technologies for the industry. We also really glad to connect with a network which provided by EIT RawMaterials, and we already found a lot of clients from this field. And we're really happy that we can connect the business part and the scientific part from our company and also from the companies from our partners. Our competitive advantages, we're really proud to have our additives with carbon nanotubes with purity 99.5% compared to the industrial carbon nanotubes from the competitors, and we also can modify our technology to each of final applications. Our technology is protected by 2 unique know-how and we are really proud to have our scientific team with experience more than 20 years in nanotechnologies field. Me and my colleague Maria, we are running a business part of the company, and we're really happy to be supported by 3 accelerated program from Latvia, Slovenia, and of course from EIT RawMaterials. We went through the phase 1 and phase 2 and really hope to participate in phase 3. We'll already also applied for phase phase 3, and for the phase 3 we're planning to also to show our 2 different technologies for the filaments and for the metals. And our aims for the end of the year 2020, because it was really challenging years for us because of the COVID situation and so on, and for the next year we're launching our additives for the market, establishing small-scale production and fundraise to do it. And currently we're looking investor to start our production and start to sell and show our products to the market. So let's print real things for real use, and I'm really happy to participate in this event and to show all our company's technologies. Thank you.
Thank you very much, Marina. From 3D Strong. With me here now, I have also Rami Niinikoski, and he will be presenting the company called Kierto Environmental Services. Right. Yes, we are very happy to have you here, and we have been working together with you. Our collaboration started pretty just a few months ago, actually, and yes. We are eager to hear more about what you are doing.
Thank you. Okay. My name is Rami Niinikoski. I work for Kierto Ympäristöpalvelut Oy, or Environmental Services, as said. I work in sales and marketing, and I'm also in charge for our current project that we are collaborating with the EIT RawMaterials. I'd like to start with a few words from our company, what we do, what's our story, where do we come from. I work in sales, so I always like to talk about my company and find perhaps some mutual grounds for somebody to make sales. So our company was founded in 2009 by 2 individuals, Mr. Antti Eriksson and Mr. Juha Revsten. And the both of them had the similar idea that maybe the hazardous waste market in Finland is pretty narrow. It had only a few companies operating in it, and of course Ecochem, now Fortum, is and was the biggest company, and they had a sort of like a one-sided way of doing business. So we started to think that maybe there's room for an agile, small, flexible company like us. And 11 years after that, we can see that there surely has been. So I'm just going to go through the key figures and net sales. You all can have this material afterwards, so I'm not going to go into that much detail. But we have 3 locations currently. We have in Ilmajoki, and then we have in Kuusankoski, and of course in Järvenpää, where we have our headquarters. And we're currently investing in our future treatment facility in Vaasa. And we're of course investing currently in our Järvenpää, our headquarters, and the main treatment facility. So what do we do? Of course we have the holistic hazardous waste management service for business to business sector in Finland. We don't work in business to consumers, mostly because hazardous wastes are produced by companies in the big scale. And we work with communal companies for the consumer wastes. We treat approximately 90% of the waste streams that we take in by ourselves, and we try to incinerate as little as we can the waste. So our core business idea is to utilize the hazardous waste streams as much as we can, and differentiate from our competitors in that way. Because of this idea of utilizing waste, there has become a new idea of turning wastes into products. This is very common in the traditional waste streams: paper, metal, glass. But it's a new idea in the hazardous waste business. And we currently have had 4 different ways that we have taken the end of waste process and made it a product. So we can sell it onwards, and it's no longer considered as hazardous waste by law. And this idea that we have been doing has given us a great competitive advantage over and over in our company. Of course, we have environmental consultant services, and we have this kind of safe disposal of products where we take perhaps a shoe that looks like a Nike shoe but isn't, and you have to dispose it away from the market in a secure way. So that's how we do it. As already said, we have 3 locations currently with different emphases on different waste streams, and most likely we will, in Valkea or Kuusankoski, we will invest in the next 2 years to have different waste streams that we can treat there as well. All in all, our capacity is approximately 50,000 tons per year of hazardous wastes. So the interesting project that we are doing with the EIT RawMaterials is the AREC project, which is aimed at the hot dip galvanizing industry in Finland in the first stage. We can expand the business as well to PCB production, printed circuit boards, but as we all know, in Finland we don't have anymore so much factories that produce printed circuit boards than we did, let's say, 15 years ago. So we are concentrating now on the hot dip galvanizing. The idea is that we will receive the waste that's hydrochloric acid that has diluted metals in it, mainly iron and zinc, and we regenerate the acid by distillation, and we return it to the customer so they can reuse it. And then we turn the diluted metals in the process as a metal salt that we can sell to the markets with various different uses. So that's a comparison to the method that's used most currently, and this will give us a competitive advantage, but I will discuss that in a few slides up ahead. The revenue generation model is, of course, currently that we can charge the company a gate fee when they send us the waste, and then we can have a price when we sell the product. So it's a two-way coin that works beneficially for us. But at the same time, we can give the customer a much cheaper price for the treatment of the waste, and of course, they can have a sustainable and environmentally better solution for their waste. So this is to give you an idea to the people that doesn't know the hot dip galvanizing industry. I'm not an expert as well. I'm a waste management man. So this is the process of hot dipping a metal product in the industry. And there's a pickling phase where they use hydrochloric acid, and that's our raw material that we use in our process. The pickling acid is changed when it comes too fluctuated with the metal. So the metal content is something approximately 20 to 25%. And after that, the pickling phase takes too long time, and they have to change the bath. And then they'll send it to us. So what we do with the waste, and I was talking about the competitive advantage. So this is how it's treated currently. This is how our company is doing it as well currently in Finland. And the next phase is the distillation method. So the waste is treated in a physico-chemical plant. It's neutralized. If you have an acid, you use some lime, and then you get the pH to something like a 7, and then you take the metal out in a sludge form, and then you can drain the water after it's purified to the waste management system, to the drainage system, mostly a communal drainage system. And the metal slag that is produced is currently, if you have iron on it, there's no actual value for it. So it is dumped in a hazardous waste site. This is our method. So there's two possibilities that we can input this to the market. Either by a company like us, it depends on the market. You can have a treatment facility that is separated from the original product site of the hot dip galvanizing. And this treatment site can receive the waste from various different locations. This is the business model that we're using in Finland because the hot dip galvanizing plants are not so large. So it is good to have, we have approximately 13 plants in Finland that produces roughly saying 1,500 tons of hydrochloric acids per annum. The capacity of our treatment plant is 2,000 tons per year. So one plant in Finland can treat all of the waste that is accumulated in the companies. We are looking at the European scale. We have some market research over there, so we are estimating that there is 1 or 2 factories that can get that. This method could be implemented inside the plant as an end process where they could circulate the acid ongoingly. So there's the 2 ways we can build the factory inside the factory, and so there is a continuing distillation and purifying process, and then you can get the metal salt out of the process, and you can sell it, or you can utilize it in your own production if it's possible, depending on the metal quality. But definitely you can sell it to another production facility in another industry. And thank you. If you have any questions, I'm more than happy to answer.
Thank you very much, Rami. It's a pleasure to have you here and to hear more about Kierto Environmental Services. You are the 4th, and now we're moving forward to the 5th speaker in this session, where we are presenting different projects that we have been working together with here at the Innovation Hub Baltic Sea. With us from Norway in Oslo, we have Kumar. He will be joining us on Teams. He's online, and we will be helping him also with the presentation. So please bear with us if there will be any smaller interferences.
Yes. Hello. Thank you.
Hello, Kumar. How are you?
Yes, we are fine, and thanks for your invitations. This is our privilege to be in stage right now. So I would like to start about the company Nanopower. We belong to Norway and Oslo. And we found the company in 2016. And we're producing a nano silicone after 20 years research. You all know crystalline nanosilicone, you can apply different applications, such as painting, solar panels, and batteries, and like this, different markets. So for us to decide the market segment is the most important things. Why? This is the thing is you are winning the game or you are losing the games. So we tried a lot of time to investigate the market carefully. And after the investigation, we want to go to the battery applications. The reason is 2 main reasons. One is we want to support environment. That means the renewable energy. And second thing, it has a very good capture value. That's also interesting for us. So that's why we choose this market segment and the battery field. So next slide. So when you see the business view, you can see clearly we have 2 different raw material we are using. One is silicon ingot. Second one is juicing from the residual from the solar productions. The silicon ingot, when we are juicing, I know a lot of companies, they are trying to produce crystalline nanosilicons. But luckily, we succeed. Thanks for our scientist, the co-founder Hiroshi. And second raw material we are using, they call this silicon microsphere. So when you think about this, solar panel we are talking about, it's a good for environment. At the same time, it has a side effect everyone knows. The wastage of this silicon wafer, it can be environment huge problems. We try to bring in the EIT. Then 2018, we got support from them. So we are very happy. But the problem was there, we got only 2 months. So we know a lot of publication, you can find it there, a lot of person trying this method. So I tell to my team, okay, can we take the challenge? So all said yes. Then I told them we have only 2 months, but practically we have only 6 weeks. So we try hard, we succeed to produce nanosilicons from the wastage from solar wafer. Actually, what we are doing, we are taking the wastage to bring to the battery application, getting a value for that. So in the middle of the photo, you can see our SEM photos. It's a microscope, electron microscope photos. There is a size for we are producing 70 nanometers. So next slide. So when you think about value propositions, everyone knows when you compare graphene and silicon, silicon is a 10 times much capacity. But our manufacturers test our material. One of the manufacturers tell we have just 1,000 different material. Kumar, you have a unique one, which is no one has. And now they are producing a second generation lithium-ion battery with a 3 times capacity than the battery which is in the market right now. That means you can have a car, you can drive to 1,000 kilometers without charging. So then I asked them why you are driving, keeping a kilometers, 1,000 kilometers. Then they are saying because this moment Kumar market needs only 1,000 kilometers. And to improve this more than 1,000, it has a lot of challenges. So we know already getting inside battery is a challenge market and difficult to get inside contact with the customers who is producing a batteries. But we are lucky, we got already 5 customers. They are huge. In Europe, we have 2 customers. And we have Asia, we have other customers. So next slide. Mia, can you go next slide? Yes. What you achieved so far, we invent one reactor we call production machines, 2015, after 2 decades research to producing nanocrystalline powder. That was 2015. And 2018, we got financial support was provided by EIT RawMaterials. And then we are using a raw material silicon wafer scalp. And 2019, we developed the 8 generations reactor, or you can tell production machines, which is have a much capacity. We are talking about 200 kilos per month. And it's a fully automatics. And 2020, we decide now we are selling our powder, not for testing. We deliver a lot of kilos to our customers. Then 2020, we decide now we want to sell the powders. And we are selling at very good prices. And now we have decided we want to upscale 200 tons per year. Can you imagine? 2015, we produced 1 gram per month. Now we are talking about 200 tons in 2028. It's a huge step. It's involved a lot of effort we have to put. So then you can go next slide. So usually a lot of company, they are getting exit from Europe. They are going to Asia or they are going to States. What is we are doing, the wonderful thing here, we are bringing a technology from Japan to Europe. So this is a very unique, we are bringing actually technology from Japan to Europe. So then you can go next slide. So you may ask why we are bringing to Norway. Labor charge is expensive. There's a lot of challenges. Yes, there's 3 major issues is here. One is we are getting a very good pure raw material silicone from Norway. We have a lot of silicone from Norway. Second thing is we are using electricity. It's a very cheap than in the world. And the last thing is electricity comes from hydropower, not from other resources. So that means we are supporting 100% clean energy. Our production method doesn't have any toxic gas or any wastage is going on. Everything is fully packed, fully automatic. There's no wastage going from the factory. We already established 7,000 square meters. We didn't have nothing when we start 2015. Now we have a 7,000 square meters factory. The ambition is we want to go for 45,000 square meters with 2 factories. So when you go next slide, please. Yes. Here is the most important thing I would like to share with you. You know, every time when you start a company, there's a lot of different barriers. Human beings, you need to have the resource, different thing. Most challenge, raise the money from the investors. Mostly it can be difficult sometimes. So you will get the money from the seed monies or venture capitals. And we got a lot of our from the different investors. So we decide to say no to all of them. You will ask why we are saying no to investors. This is extremely different situations. That the reason is, first of reasons, this is not talking about money, our business. We are talking about society. We are talking about environment. A lot of employees, customers, and who is delivering the raw material, they are putting their faith on our hands. We don't want to let them down. So when we go into the investors, always they are talking about return of investment when they want to get exit. That means we lost the control of the company. So that was a huge challenge. When we start the company, we face it. How we can keep the control. Then that's a wonderful thing. It's happened from the EIT. 2017, I got contact with the EIT. That was a miracle, I want to say, that day I get the contact with the EIT. And they support us 2 times already. 2018 and 2020, we got a huge support from them. And not only financial support, we got a lot of network systems, and we got developed different knowledges from them, their advices. It's one of the things we found it's important organizations helping to start up. That's EIT. And I want to thank you everyone listening, Nanopow. And thank you so much. That's all.
Thank you very much, Kumar.
Yes.
For those of you who want to know more about Nanopow, you can visit EIT RawMaterials.eu. Olli, do you have some final words for us after this day?
Yeah, I guess this is the end of the 6th Stakeholder Day of EIT RawMaterials Baltic Sea Hub. It's only the beginning, of course, our work together with our partners and other stakeholders. I'm tempted to draw a few conclusions, which is always dangerous in seminars and events like this, where there are a number of different angles to issues. But a couple of take-home messages maybe that I wrote down for myself. So the first one was, indeed, in these times that we live in, there seems to be an inertia, if you will, in the R&D activities that we make. So there's still a momentum in the activities that we make, in the innovation between industry, between research organizations and universities. However, when the reality kicks in, when that momentum takes out, then we need to see that we actually have the real means to get over the pandemic and the crisis that lies ahead. And this can be only done, in my view, with sufficient inputs and support to the R&D infrastructure and projects that are run in Europe. The second point, of course, touches a little bit about prioritization. So what should we focus on here in Europe? And listening to the presentations today, it's quite clear that we need to prioritize. We need to see what are the most crucial, most critical, most valuable supply value chains, material flows to Europe, from Europe, and within Europe. And with that kind of prioritization, we can then start looking where to put the investment into the value chains, into innovation, and get really the jobs and growth that we are expecting from our joint activities. So that, in a nutshell, also describes really the aims of the European Raw Materials Alliance, the ERMA, to get innovation and investment moving in Europe in the raw materials field. I would like to thank all the presenters today, both online and here in person. Well done, in spite of the technology not always being on our side, but I think we did and you did a good job. I would very much like to thank the audience online. Please stay with us in the future as well. The next step, and the next time you will hear from us, is on the 29th of September, when the Raw Materials Summit takes place. It ends on the 30th of September. Also on the 29th of September, please remember the launch event of the European Raw Materials Alliance. Please sign up there as well, so you get the latest info on where this part of the innovation ecosystem is developing in Europe. So with that, the Baltic Sea Innovation Hub from Espoo, over and out. Have a great day. Goodbye.